Actually, Matheus, you can now put your camera and microphone on, and then you'll come onto the stage.
Okay, I think
so,
we're on.
Welcome everyone to our, I think it's our third Partner Connect session. We're very lucky today having Matheus Grasselli, who's a professor of mathematics, and he's going to talk about his work, and then we will have a Q&A session. So I'll leave it to you, Matheus. You can put your, you can share your screen, and if you want to, and give us a little bit of an introduction. Thanks very much.
Thank you, Henry. Yeah, so I didn't prepare a formal presentation. I thought I should just tell you a little bit about the institutions that I'm representing here, and then that can serve as an entry point to my own work, and then can go to questions and discussions, which is always the most interesting part. If I can just share my screen here, I can show you a couple of websites. So the logo that you have table is for McMaster University, and it's for the Department of Mathematics and Statistics. So this is the department that I'm the chair of. And so it's McMaster University is located in Canada. It's one of the top universities in the country. We're just coming out of a Times Higher Education ranking that puts us in one of the 70 top universities in the world. So everybody around here is proud of that. The Department of Mathematics and Statistics is a large department with research in all areas of pure and applied mathematics. But what I'm highlighting here to you in the research part, so these are the different areas, but the financial mathematics area is the one that I'm most connected with. So these are the researchers in financial mathematics, and we have graduate students, we have postdocs, and it's a group that's been established for many years. And in particular, the group has refocused since the financial crisis in 2008, and then a few years later, when we had a chance to absorb what was going on in terms of research, we refocus our activities on areas of particularly related to financial instability and systemic risk. So in partnership with the University of Toronto and the Fields Institute, which is a research institute for mathematics in general, but also with a lot of activity, workshops, conferences, seminar series in the area of risk and financial mathematics. So the institute formed this laboratory, the Systemic Risk Analytics, and you can see the description of it here and some of the lab leaders. So I'm one of the lab leaders, my colleague Tom Hurd from McMaster, and our colleague Sebastian Jaimungo from the University of Toronto. And here you can see the graduate students and postdocs and other members of the team. And so what do we do in the lab is address issues of systemic risk in a broad sense. So going from the nitty-gritty of market microstructure and algorithmic trading and what goes on in financial side of things. We have an industrial partner, Oanda, which is a currency trader, so we get a lot of insight and good market information from them. But then ranging from what happens in banking networks, we're very well connected with regulators in Canada. One of the partners is Ian Buckley, who's at the regulatory agency, the Canadian Securities Transition Office, and several other people here. For example, Gregor Schala is a researcher at the Bank of Canada. So we also have access to the latest in-house research that is done at the Bank of Canada on issues of stability of the banking system, the Canadian banking system and the North American banking system. But then also going a little bit more broadly, we are connected now with the OECD. The OECD has a lab called the new approaches to economic challenges. And through that partnership, we're working on issues of climate risk and finance. So how both climate change affects financial risk because of portfolios and investments and stranded assets and things like that. But then conversely, how financial markets and financial instruments can help transition to a decarbonized economy, and how things like bonds and green securitization and even more broadly green central banking could help accelerate that transition. I think that's all the sites that I wanted to show. So if I go back here and maybe I stop sharing the screen, maybe I can take questions now, because we can take this in any direction that people might like to go. Was that too short, Henry? Or
no, that's a great start. And while people are thinking about questions, I might start with a question. And one of the things you said is that since the crash, you've been taking in its significance for financial mathematics. I wondered, what has been the biggest impact on your area of research from the crash in terms of, new directions?
Yeah, so it's the emergence of the area of systemic risk as a research area. So it was in a fringe area before the crisis. Very few researchers were putting as research questions, what is the stability of the banking network, and if a certain bank introduces a product, how does that affect the rest of the system? So this was in the radar screen, but only for a small number of people. The majority of the community was researching, things like derivative pricing, but then the derivatives would become more and more complex, and this led to the some of the villains in the 2008 crisis, the collateralized debt obligations and collateralized mortgage obligations, and all of those issues of securitization. That was very, very much the core of the subject prior to the crisis, and that has died as a research area because it died inside the banks. Like the volume of transactions that were done with the complex derivatives, it's practically non-existent now. Meanwhile, there's been a lot more emphasis on, for example, even if you have a very simple derivative, a very simple contract between two banks, but each of the banks has the risk of failing, the risk of default. So how does the risk of this bank failing affect the valuation of the derivative that is that bank, and vice versa? So this is called counterparty risk. And counterparty risk also was very minor before the crisis and acquired a lot of significance. And counterparty risk then became part of a valuation of derivatives. So this goes under the name of credit valuation adjustments and things like that. So, many new brand new research areas were created because of the crisis.
And I wonder, one of the groups that I'm working with is the Institute of Actuaries in the UK, who there's a guy called Oliver Bettis who works there, who actually knows Steve Keen. I met him through Steve Keen, who obviously you know very well. And they're going through a soul searching around the tools that actuaries might use. And of course, they're interested in long-term valuations. Is there any work that you've been doing looking more at long-term valuation?
Not that I've been doing directly, but yes. So that also got some emphasis after the crisis. A lot of the paradigm of financial mathematics has always been what's called risk neutral valuation, and risk neutral valuation is all market based, and it takes on the immediate views of the market and the relative pricing of things that go on in the market. But that can change very rapidly, and then what's called the risk neutral probability can all of a sudden be very different from what you were doing before. So there's been a renewed emphasis on what's called, surprisingly, real world valuation. So real world
real world valuations.
That's right. That's actually how it's called, and how it connects to derivative pricing. And so the things called the benchmark approach, which look at long-term benchmark instruments. So, for example, some composite index for the entire market and how it behaved over decades, and going back to the maybe the beginning of when the S&P was established, and so on, and try to extract properties of that, and then do valuation of equally long dated future derivatives based on those properties, but done it very consistently, and also consistent with what you see in the market presently, because you cannot ignore what's going on in the market presently.
It's very, I know I've come across a sort of investment advising organization that I think was called something like Citadel or something like that. And basically they say they analyze the whole history back, of what shares have done best. But then I thought, when you do that, of course, history is contingent. The last 80, 90 years had particular properties. And I suppose one of the key ones, was American hegemony. And not just in terms of the dominance of the US dollar, but also in terms of their power dominance in obviously they won the First and Second World War, and that was obviously important. But what shares have maintained value over that long period. And of course, if we look to the future, it's not necessarily true that the US will retain hegemony in the way they have in the past, obviously with China challenging that. How do you deal with that sort of thing? Because if the Chinese currency became dominant, the dominant world currency, that would change a huge amount, wouldn't it?
Right. So that is of course a deep philosophical question, and it has to do goes back to issues of can we use the past to make statistical predictions for the future, ergodicity, stationarity, and so on and so forth. But I think that's where it's important to have broader models that don't look necessarily only at financial markets and properties of financial, because financial markets are, after all, connected to the rest of the economy. And I think this was, you mentioned soul search, and I think this was a lot of what went on with researchers in financial mathematics as well, to not only actuaries, to see how the work that they were doing in the narrow domain of financial markets connect with larger domains. And that's how I got involved into doing macroeconomic research in macroeconomics, and that's, you mentioned Steve King. He was my point, and so it turns out that these models that look at the dynamics of the broad dynamic outlooks of things like credit and financial flows, and how where are savings going around the planet. So you mentioned China and the Chinese currency, but it's not just an issue of currency; it's an issue of trade balances and which way they're going, and saving lots and things like that. So if you and not just one model, but a collection of models, and those models have to make predictions, and what you do is then sort of rebalance your views about the models, and the well-defined ways of doing that using Bayesian statistics, for example. So that's also some of one research project that I'm involved in how to make comparisons between potentially very different models based on the information that you are receiving, and then extrapolation to the future. So in a way, the broad changes in geopolitical situations that you mentioned could be taken into account by having models in which they are important, gaining weight in your collection of models, if that makes sense. So they have a low weight for a while, but then they start to be more dominant after a certain time.
And do you think models have influence?
Yes, massively. So for one thing,
there's models. What I'm saying is there are one model that has been hugely influential is the sort of household model of of government that Thatcher introduced, and we've got to balance our books and we can't overspend. That seems to me a hugely influential model, but of course it's not really a mathematical, it's not even good economics, but it is a model, i.e. a sort of story of how the world works. But you're talking about hugely complex models and multiple models and so forth.
Yeah, but they don't need to be hugely complex. They can be simple models, and they can have simpler versions that also tell what you're talking about as stories, right? So there's a household picture. It's a story that comes out of some form of modeling, and so models can have influence if you are in charge of a huge portfolio and you need to decide how to invest, and then you need to arbitrage very carefully any mispricing and so on. And then that's where the complex models play, because they're looking for anomalies, and they're going to look for those things that are not like visible in the simpler models. But that's only one part of the story. So equally important is what you mentioned, is how models provide a lens to understand what's going on around. So if government says now we're going to be spending because there's COVID, and is the right question to ask how are we going to afford that, or the right question to ask are there resources, physical resources for it, and then the affordability, the financial affordability is a secondary matter. So this is also, so you have to express those ideas in terms of might not be a mathematical model, but it's a frame for thinking.
And do you think, like, take the systematic risk analysis and trying to think about the world like that, do you think that is getting out there more broadly as something we have to do? Because I mean, we talked about system thinking and so on, and obviously in policy that's sort of coming up a bit, but in the world it doesn't seem, I don't know, do you think there's anyone out there who's good at telling a sort of systems thinking story?
I think so, and the OECD and the Nike laboratory, they're doing a very good job at that. So for example, because of COVID, they created a seminar series, exit strategies, and you can just go and check, and there are many people there. So there's some very conventional economists that went there and talked, like Larry Summers, but then people presenting this more systemic view, and even relating to issues of how organize supply chains, and what does climate change have to do with that. So I think, and COVID in a sense was the kind of a perfect shock for us to focus on systems thinking, because almost by definition is something that is governed by the internal dynamics of the system. What people do, how people react, what kind of traveling, and what kind of trade, what kind of relationships that people have. So and the totality of the people, right? You cannot understand an epidemic by talking one agent. So the whole story of the representative agent falls into pieces if you're looking at phenomena like epidemics, right? Quite evidently.
I totally agree. I'm just looking, we haven't got any questions, I think. Does anyone, I think,
do we have participants? We have some attendees.
Questions. Don't feel you have to understand everything, because ultimately Matheus has to put things into terms, and I think he's very good at that are non-technical and make sense to someone who's not versed in mathematical modeling and systems theory and all sorts of things. So do ask, don't be afraid for asking what seems like a basic question, because it's probably really on the spot. But while you're thinking about it, I'm going to ask Matheus one more question, because you did mention at various points the sort of climate change link. So what are you looking at in terms of climate change? How does that factor into financial mathematics?
Yes, and macroeconomic models, the three things come together. So the currently most used type of model for understanding change in the economic context, not in the climate. So the climatologists are very sophisticated in using, in fact, the type of combination of models that I've been talking about. They don't use just one model. They use models that go in many different scales, and they combine the predictions and have distributions over predictions and so on and so forth. So that's not what I'm talking about. I think I have very little to say other than great respect and trying to understand the climatology. But then when it's combined with economics, the way that it's done is by using what's called, just to use a technical term, it's a dynamic stochastic general equilibrium model. It's a growth model that looks at the economy as something that it's in equilibrium path at all times, and it's sometimes knocked out of this equilibrium path by disturbances, and the disturbances are misunderstanding and lack of information, or some little perturbation that happens. But as soon as people come to terms with that, it goes back to this equilibrium path, and the equilibrium path leads to growth and sustainable employment and growth of wealth all around. Well, that just doesn't square with climate change, where the type of disturbance and the type of shock that you're going to have there can lead the economy to a very different path that doesn't self-equilibrate and doesn't go back to growth. So what you need is abandon that modeling framework and replace it with something that allows for multiple equilibria, allows for even constant cycles and disequilibrium, chaotic behavior, or simply allow for the possibility of crashes, something that in the future is going to crash, and agents are not going to self-correct just because it's something that it's not going to be sustainable. There are feedback mechanisms that lead to a deviation from a good growth equilibrium path that are not self-correcting, and then you need to do something more drastic to correct it. You need more policy intervention. You need to actually have incentives and also ways of financing those incentives. So it's combination of the disequilibrium nonlinear dynamics that you normally already see in climate, and things that I'm talking about are like tipping points that you have a certain trajectory for, say, emissions, but you can have certain feedback mechanisms that lead to wildly different trajectories because, for example, there's the melting of permafrost, and completely changes the dynamics. So that you should have in the economic model as well. For example, you should have things that, as firms accumulate an unsustainable level of debt, and they might even be doing that because of the effect of climate, because there's some losses that climate introduces, or because they are trying to do abatement costs or mitigation, and they don't have enough financing to do that. So that leads them to a situation where, again, it tips over to a different dynamics. There's a point, and the tipping point, but it's an economic tipping point. It's not a climate tipping point. But the two things go together. So, and it's not just me, but there's a large group in France at the Agence Française de Développement, which is investigating this. It's the idea of using the same sort of non-equilibrium dynamic model that one uses for climate, but for the economy as well. And it turns out that it's much more, it's much richer and allows for a lot more exploration and also more realistic.
Brilliant. Well, thank you very much, Matheus. That's been fascinating, and I hope that the audience has enjoyed it. And we will be putting this up on the YouTube and promoting it, and I think there'll be a lot of interest in it. So thank you very much.